Hi everyone. Today we are going to discuss about Newton laws of motion, second part. Okay, so first part we discuss the important concepts, atwood missions, and what is a free body diagram, how to draw the free body diagram, and then we see the few previous year questions of NEET JEE. Okay, so now that is a continuation part. A second part will discuss previous year questions, solving problems and mechanics. Okay, so we'll take one previous year problem. This is a previous year problem. The first, read the question carefully. A block of mass m is placed on a smooth inclined wedge. So this is our block of mass m and placed on a smooth inclined wedge. ABC of inclination theta. So it has some inclination theta as shown in the figure. The wedge is given an acceleration A towards the right. Now we are applying some acceleration A to this wedge. It is moving towards right, this direction. Then the relation between A and theta. So what is the relation of this A acceleration and theta for the block to remain stationary on the wedge? Means the block has to stay on a wedge. So what is the acceleration? Even though we are moving that wedge to some acceleration A. Okay, that is the question. So here we have to know the concept. First, pseudo force. What is meant by pseudo force? In order to solve this problem, we have to know the concept called pseudo force. So FPF. Pseudo force is nothing but it is not a real force. Okay, so it is not a real force. Okay, it is a virtual force. And where we can use our pseudo force means pseudo force we can use in non-inertial frame. Non-inertial frames. Okay, so we have two inertial frames, inertial and non-inertial frames. Inertial frames and non-inertial frames. So inertial frames where the Newton laws of motions are Newton's laws are valid. Okay, non-inertial frames means Newton laws of motions are not valid. Okay, so what is meant by non-inertial frame means here the observer are also moving. Observer will also moves with respect to source. Okay, so that is our pseudo force. And pseudo force FPF is equal to M into A with minus. Minus represent opposite of applied force. FPF and A is the acceleration of observer. And M is the mass of object. Okay, so this is our pseudo force formula. Now here, if you observe in our case, this is not a inertial. In our case, it is a non-inertial frame. Okay, it is a non-inertial frame. So in this non-inertial, why we are telling it is a non-inertial frame? Because the wedge is moving. The wedge is moving. So wedge is also moving. So it is a non-inertial frame. So our Newton laws of motions are not valid. Then we'll take our pseudo force. Now we have to draw the free body diagram of given system. So like this here we have, this is our block and here our normal force. So this is our normal force and this is our force, and here the normal force resolved into two components because it is inclined with some angle theta. So this is theta. If it is theta, this is n cos theta, and this is n sine theta, and this is n sine theta, and pseudo force we know that. So applied force is A. This is the forward direction. Means this is our applied force. Pseudo force is opposite. So this is our pseudo force. That is M into A. That is F pseudo force. Okay. Then our mg will be downward direction. This is our mg. Okay. Now what we need to find? We need to find the acceleration. What is the acceleration? Okay, so from free body diagram, horizontal forces and vertical forces we can equate. First, n sine theta is equal to m into a. Let us take equation 1 from horizontal and vertical. Vertical, n cos theta is equal to m into g. Equation 2. Now if we divided both, n get cancelled, get cancelled, tan theta is equal to a by g. Then acceleration a is equal to g tan theta. So our option 4, option D is our correct answer. A is equal to g tan theta. Okay, and this is one of the JE. Also they asked this question, same question. Okay, clear? The next, we'll see another problem. Now, again, try to understand the question carefully. So we have two blocks, A and B of mass is 3m. One block of mass 3m and another block of mass m respectively are connected by the massless and inextensible string. These are connected with the inextensible string. So let us take, this is our string. Okay, the whole system is suspended by a massless spring. And this whole system is suspended by the massless spring, as shown in the figure. The magnitudes of acceleration A and B. So what is the acceleration? That is magnitude of A, and what is the acceleration? The magnitude of B. When condition is what here? Immediately after the string is cut. After the string is cut, what are the accelerations? Okay, so that is important, that condition. Okay, now, so here we have to know again force, the spring force. Spring force F is equal to K into X. Okay, this we have to know. And our problem we can categorize into two. So first one is before string cut. Before string cut. So what is the free body diagram for 3m mass? 3m mass, what is the free body diagram? So here we have a spring. So that is a spring force, a restoring force. F is equal to kx. And downside, so it is a 3m mass is more. So tensional force also down, and mg also will be downward. Then spring force F is equal to T plus mg. That is for 3m mass free body diagram. And for mass m free body diagram, for mass m free body diagram, mg gravitational force, this one mg means here how much mass it is 3, so 3 mg into 3 mg. Okay, so and tensional force will be upward, then tensional force is equal to mg. Let us take, this is equation 1 and this is equation 2. Now equation 2 in 1. If you substitute 2 in 1 means tension, in the place of tension mg, then what will get? F. Our F is equal to kx. Kx is equal to mg plus 3 mg. Then our kx is equal to 4 mg. Okay, let us take, this is our equation 3. This is the condition of before string cut. Now we are cutting the string. We are cutting string. When we cut the string, tension is equal to 0. There is no point of tension. Then what about 3m mass? Our 3m mass will go upward with acceleration A. And here a spring force Kx and gravitational force 3 mg. Then net force is equal to, which is more, kx minus 3 mg. And net force is what here? M into A. So that is 3m into A. Kx is how much? Here 4 mg. So 4 mg minus 3 mg. Then 3 ma is equal to mg, cancel. A is equal to g by 3. So that is our first acceleration of A. And the second one here, if you observe, B, when it is cut, it will come free falling. It is a freely falling. If it is a freely falling, acceleration is what? Acceleration is equal to acceleration due to gravity. AB is equal to G. Then G by 3 comma G. That is our answer. Okay. Clear? Then next, another question. This same related that spring question only, related that one. And here balloon. And read the question carefully. So we have a balloon with mass m is descending down with an acceleration a. So up to, we'll stop. So we have one balloon. It is descending downward with acceleration a. How much mass should remove from it so that it starts moving up with an acceleration a? Now, how much mass is removed so that the balloon will move upward? That we have to find. Okay. So now we'll take acceleration is coming downward. Mass, let us take m into g, and the m is our total mass of the system before mass removed. And here we have force. That force is upthrust force. Okay, so upthrust force F. Then how we'll write this one? Our up here net force. Net force on the first case is equal to upthrust force. Upthrust force here lesser. Okay, so mg will be more, mg minus F. Let us take equation 1. Because it is coming down, mg is more, upthrust force is less. That is F net. F net is nothing but m into A is equal to mg minus F. Okay, let us take, this is our equation 1. Then for second case, now we are removing some amount of mass. Let us take, that is m naught mass. Then total mass, that gravitational force is mg. Here it is m minus m naught into g. That is our gravitational force. And same way upthrust force is there. And second case, total mass means net force is equal to m minus m naught into A is equal to, it is moving upward, so upthrust force will be more, F minus m naught into G. Let us take equation 2. Now from equation 1 and 2, if we separate here force from equation 1, we can written as F is equal to, how to write, mg minus ma. And from equation 2, F is equal to ma minus m naught A, again minus mg. This will come to left side, means plus mg minus plus m naught. It will come that side, means minus m naught into g. Now if we observe equation 3 and 4, force same. If we equate mg minus ma is equal to ma minus m naught A plus mg minus m naught g. Then mg get cancelled. Minus ma will come to this side, means plus. M naught A will come to this side, means m naught A will come to this side positive, plus m naught g, this will come this side. This is also positive. This ma will come to this side, ma. Okay. Then here m naught we take common, a plus g, and a and ma and ma. So ma into 2. What we need to find? M naught. then m naught is equal to 2ma by g plus a. So that is our answer. This one. Okay, clear? Very simple. Basics, if you know means we can solve easily. Clear? Okay. The next, another question. We'll see question. So every question keywords are there. We have to remember the keywords and we have to identify. Okay, so three blocks with masses m, 2m, and 3m are connected by a strings. Okay, so these strings connected with the three masses. After an upward force F is applied. So here upward force F is applied on block mass M. On this block mass M we applied. The masses move upward at constant speed. They are moving upward with constant speed. Constant speed. This is our keyword. Constant speed V. What is the net force on the block of mass 2m? What is the net force on the block of 2m? And G is acceleration due to gravity. Okay. So now if we observe in our case, keyword is constant speed. If it is a constant speed, force, net force is equal to what? M into A. And acceleration is equal to what? Change in velocity by time. If we take the magnitude, is nothing but speed. And the speed is constant. Speed is constant means there is no change. It is zero. Then acceleration is equal to zero means net force on the block will be zero. Then the total force on each block is zero. This is about zero. So few questions will be like that only. They will ask in exam. You have to be careful while identifying the keywords. Okay. So this is our part 2. Okay. Thank you. Next questions we will see in our next part.